Welcome to this presentation of industrial phosphates and wastewater impacts. My name is Robin Deal. I am a wastewater specialist working for Hubbard-Hall. I started my path nearly 10 years ago as a licensed physical chemical wastewater operator in North Carolina. I worked for a large hand tool manufacturer running 4 wastewater systems. When the facility I worked at was closed, I made the decision to join Hubbard-Hall rather than relocate out of state. Since then, I have helped numerous manufacturers solve challenging and complex wastewater issues across the country. Excessive phosphates in wastewater contribute to algae blooms. When an industry that has high levels of phosphorus in the wastewater that they produce cannot successfully remove that phosphorus to the EPA standards, a variety of things could happen. If that industry holds a pre-treat permit, the receiving treatment plant can decide to add surcharges to help offset the cost of treating the extra phosphorus. Fines could also come into play if the receiving plant cannot remove the phosphorus to within their discharge limits. If the industry holds an NPDES permit, they can be held accountable for damages to the receiving waters. Stiff fines could be placed on the industry. There are many forms of phosphorus in industrial wastewater setting. In metal finishing, phosphorus could come from zinc phosphating lines, iron phosphating lines, manganese phosphating, phosphoric acid bright dips, accelerated mass finishing that utilizes phosphoric acid, and phosphate cleaners. While little known in the metal finishing world, bacteria can be a way to solve any number of wastewater issues, including high phosphorus removal. Phosphorus accumulating organisms, also known as POAs, store phosphorus in their cells as polyphosphates. They can then use the polyphosphates as an internal energy source without the need for an external electron acceptor, such as oxygen or nitrate. While many metal finishing treatment plants struggle with a cost-effective way to remove phosphorus, they overlook this process because of limited space and time constraints. Biological removal of phosphorus can take on many forms, from huge trickling filters, otherwise known as biotowers, to smaller reactors. There are many systems that can and do work in the metal finishing world. Don't overlook this removal process because it is unknown. Bacteria can offer the solution to many wastewater issues in the metal finishing wastewater treatment processes. Chemical precipitation is by far the most common way to remove contaminants from wastewater. It is much faster than bioaugmentation, with system sizes that can be as small as a single tank to as large as a facility needs to effectively remove the contaminants. Typical wastewater systems that remove phosphorus by chemical precipitation include pH adjustment, chemical addition, flocculation, clarification, and dewater components. We are going to focus on some of the chemicals used for phosphorus removal, such as lime, calcium chloride, alum, ferric chloride, and rare earths. Calcium, usually added in the form of lime, reacts with the natural alkalinity in the wastewater to produce calcium carbonate, which is primarily responsible for enhancing suspended solids removal. As the pH value of the wastewater increases beyond 10, excessive calcium ions will then react with the phosphate to precipitate as hydroxyapatite. While the use of lime is one of the oldest wastewater treatment methods in the world, it does have its drawbacks. With only an 80% removal efficiency, lime is a huge contributor to sludge production. Fighting limescale is often a wastewater system's biggest battle as well when utilizing lime as a coagulant. While lime is one form of calcium, it is not the only form. Calcium chloride is being used as well. If using this form of calcium for phosphorus removal, a source of alkalinity will need to be added to drive the pH to the 10 range for effective removal. A drawback to this as well is that if excessive calcium is added to the wastewater, the calcium-phosphorus bonds can break down, redistributing the phosphorus in the wastewater. Alum is probably the second most used chemical for precipitation in the metal finishing world. Phosphorus removal with alum is most effective in the pH range of 5 to 7. Phosphorus was removed with 90% efficiency, and the final concentration can be lower than 1 milligram per liter. Alternately, polyaluminum chloride, or PAC, is also being used for phosphorus removal. The drawback to using aluminum in any form is that unconsumed aluminum will be in the wastewater effluent. While this has historically not been a problem for pre-treat permit holders, we are starting to see pushback from municipalities as they are starting to receive aluminum monitoring notices or aluminum limits on their discharge permits. Ferric chloride is a close third for commonly used chemicals in wastewater treatment. While easily found, ferric chloride is acidic and consumes alkalinity to remove the phosphorus. It can also cause up to a 40% increase in sludge production. When sourcing ferric chloride, it is easy to go for the cheap version that is a byproduct of steel pickling processes. But be aware that this can also be contaminated with trapped metals such as chrome and nickel. When left unconsumed in the effluent, companies can see an increase in these trapped metals and might find themselves out of compliance. A newcomer to the metal finishing market, rare earth technology has found itself to be one way to remove phosphorus while reducing chemical consumption. It can work in an acidic pH range as low as 3. It has the smallest ratio for removal at a 1-to-1 molecular ratio. But because dosing can be low, sludge production can be significantly lower as well. There are many blends as well as straight products in the market for trials. One drawback is that it can also be expensive. A full cost analysis should be completed. Additionally, as it works best at lower pH ranges, other metals that can be found in the metal finishing streams may not be removed with the phosphorus. Phosphorus removal will be an ongoing issue within the metal finishing world. There is no one fix to solve the problem. Every removal process comes with drawbacks, and each waste stream is unique to its facility. There is no one-size-fits-all in the industrial wastewater treatment. Evaluate your wastewater system with the ideal of transforming it to a lean process. While it will never be a moneymaker for your facility, it does not have to be the black hole of despair either. Thank you for taking the time to listen in. I hope you gained at least one piece of new knowledge today. I look forward to more presentations such as this one, and I hope you will continue to join in on those as well.